Hello, welcome to Building the Digital Thread with Siemens Teamcenter and Other Systems. First, we're going to start with a ProSTEP overview. Then we're going to jump into strategies on how to build your digital thread. And then finally, ProSTEP solutions and the API for the digital thread. ProSTEP was founded in 1993 out of a consortium in Europe, and our shareholders are at the bottom there, and they're mostly Tier 1 and automotive OEMs. Also at the bottom is this ProSTEP IVIP Association in the lower left. That's our sister company, a nonprofit standards body that specializes in adopting standards for engineering, integration, and data exchange. So we've always been really focused on interoperability of engineering data and, ProSTEP, meaning working within those standards as well. ProSTEP IVIP Association and the ProSTEP AG and ProSTEP Inc. Really have a strong partnership, and we were established around the same time in order to complement each other. So the IVIP Association works within the standards community to try and drive ISO or OAGIS or working groups to promote data exchange. And the ProSTEP group, ProSTEP AG and ProSTEP Inc., work towards commercial offerings for software and services, and then also supporting those standards through those processes. The ProSTEP IVIP Association has a lot of different members across the world. That includes different universities, different industries, and corporations in automotive, aerospace, manufacturing, shipbuilding, as well as system vendors. So Siemens and Dassault and PTC and others as well, and brings them all together to try and have real comprehensive view. In 2019, there was about 24 active projects in the IVIP Association. That includes things like Step 242 maintenance, right? So they were very integral in creating that standard, as well as working groups for product lifecycle information and SysML and some other. Some of the more interesting working groups that I want to kind of highlight is this cross-discipline lifecycle collaboration group, trying to break down the silos within your organization. So figure out a methodology and build some demos and tests around that for linked data and understanding what the needs are for it, and being able to provide tools for this type of linked data. And so that brought together other software vendors of different domains, brought together some OEM and supplier partners, and they were able to build some of these demonstrators and really kind of work through some of the issues and also highlight some of the success there. Also, the SmartSE project consortium, and these are different members in industry, and then also some academia and software have come together in order to try and figure out some best ways to do this cross-discipline and integration of your digital thread in systems engineering. And then also the code of PLM Openness. And this used to be called, I think, the Codex of PLM Openness, but this is kind of establishing a baseline of interoperability that we want and that everyone in industry wants the suppliers of the software in order to provide. And that might be, basic, export and import functionality, the ability to save data out or in and have good access to that data. And this is trying to just bring things together, make it easier on industry for interoperability, which is, a novel idea, but bringing together these different companies. And I think by and large, software is interested in that, in order to support their customers who have demands for this. So ProSTEP has always been kind of a neutral player within the engineering sphere. So we partner with just about everybody within the PLM, CAD, ERP, and analysis and Adobe for PDFs and things like that. And so Because of our neutral positioning, we can support a lot of different vendor-to-vendor and domain-to-domain style integrations. And Siemens, also being a market leader in the PLM and CAD domains, is a partner with us. We are a PLM Foundation partner, and they support our commercial off-the-shelf connectors for Teamcenter, for NX, TCIC, IPAM, SWIM, and Teamcenter Enterprise, and other processes for TC for SIM. Our services group is also really good at this since they are a large player within this. We have a lot of different experiences and different projects, with integration, migration, exchanging data, and also generating visualizations with the Siemens. So let's move on and discuss how to build the digital thread. So what we're seeing is this overall need for a digital thread in order to support, sustain, and organize data. So there's just more data in general, more software, more mechanical components, electrical components, larger amount of suppliers that you might be using for these, and then also more responsibility of those suppliers. And so what we're finding is that if you build the digital thread, you can validate these components and these systems earlier on, and then also have that data available later for the sustainability. And that's going to lower your overall costs by exposing what those issues are earlier on in the cycle, allowing you for correcting those, time to correct those. And then, lowering the overall cost of what these products are and the overall sustainability costs because you have the engineering intent of all this stuff, which is really important. So there are different challenges in systems engineering and the integration of these different disciplines. So the first is what I would call interdisciplinary collaboration. And this is trying to figure out what your software and your electrical hardware and your mechanical are all doing, and then coordinating changes and coordinating product development across those different disciplines. The second is really this, what we're calling vertical model granularity. And this is trying to bring what that initial requirements and product definition are and bringing that down and relating that to the software designs or the mechanical designs or the electrical designs. To try and bring some visibility of what those requirements are, what that initial functional definition might then yield as a product definition. And then the third is the verification and validation. So how do you test that, right? So not just meeting the requirements of the product, maybe up at the top of this V model, but as you go down, being able to do an analysis on mechanical designs or unit tests on software and things like that, in order to bring them back and make sure that the validation flows throughout the entire model between the different disciplines and linking the data, all together to understand the intent of the data, not just what it is. So, we see that even with the neutral formats, that they're largely silo driven, right? So if you're working within a single domain, typically you have a methodology of exporting and importing this data between different systems. Like requirements might have RecGIF, with STEP for mechanical design and testing and manufacturing, or JT, with some of the DMU and other types of functionality. But by and large, because the working groups that are focusing on this neutral formats are specific to a single domain, really they don't really bridge these things. So one exception at the top is the OSLC. That's fairly semantically weak. So but it does provide some interoperability across all these different domains. But if you really want to be able to persist data outside of a system, typically that's going to be silo driven. So we get to different use cases of what we see within this digital thread roadmap. So The first one, and this is really very common, is the replication of an EBOM or maybe an MBOM to create that data within the ERP or MRP or MES systems. And so, a lot of times you'll have a PLM data that's responsible for engineering, and you might do some manufacturing and process engineering in there as well. And then that's replicated to ERP to handle, the downstream manufacturing processes, logistics, and purchasing, things like that. And this is super common throughout a lot of industries. The second is replication of CAD data and then bringing back results to PLM through your analysis data management. So that could be SDM, simulation data management, or SPLM. And this is taking data from your product lifecycle management system and the actual binary CAD data, bringing that into your analysis data management system, performing that analysis, and then bringing the results back so the designer can update it. And this is something we're seeing a lot of traction on, within different aerospace and some automotive communities. And then, bridging that cross-discipline between software and PLM, determining the change dependencies there, system links. And so if you're in a model-based systems engineering environment, providing traceability back to the original artifacts allows you to do a clearer validation of what those artifacts are, and being able to really trace back and understand what the source data is, not just a text representation, but an actual link back to the data, as well as production scheduling and forecasting and things of that nature, and then IoT and Industry 4.0. So that could be products out in service right now and feeding back data so that you could change software on it, or maybe feedback data that shows that there's hardware issues or maybe enhancements that could be made, or also in the manufacturing process. So understanding what your tools are doing and being able to work with those tools a little bit more efficiently. So I'd like to highlight that integration doesn't just mean copying data from one system and putting it in the other system. So there's a lot of different techniques that you can use in order to promote this integration. Sometimes that binary data is needed, right? When we were talking about that SDM to PLM example, you need the CAD data in order to perform the analysis. But in other cases, in order to maintain the digital thread, maybe just the link is good enough. And then also, in order to make data usable, linking data in combination with the publishing engines of these different systems and providing that published data to the user can then, yield the results that you need. So in this case, on the diagram, if you're using doors for requirements and the Cameo suite and for system models, then you can maybe publish that requirements document, put it in a Teamcenter, have it automatically being published, when it's needed, as well as the system model. So take that, maybe just components or even whole packages of those system model, and then bring that in a viewable, usable format for that Teamcenter user. And then be able to relate that as well. So the system model might be related to the artifacts and the items in Teamcenter, or the requirements might be related to the artifacts in Teamcenter as well. So using a combination of different strategies, I think, is important in trying to find the best solution that you might have for accomplishing the task. Let's take a look at the ProSTEP API. So ProSTEP is trying to bring together different functionality and what we're calling the API for the digital thread. And this includes functionality for replication, meaning exchanging binary data and copying it from one system to another. Federation, and that means you can query from one system into another system to provide the maybe link data or update data from that system. Collaboration, and this is really an integration that goes over your corporate borders. And so being able to securely exchange data with your customers and suppliers. And then finally, communication. So getting that derived output so that you can really get things within a format that's consumable by others that they don't maybe use the same clients that you use, like CAD workstations or requirements or SysML or something like that. So at the bottom here of this diagram, we've got the different clients, and that might be CAD, analysis, software development, or requirements clients. And we don't really interface at that point, right? That's not where you're going to create a permanent record for your digital thread to relate to. And because, these are just committing to a repository, what we want to do is have the long-term sustainability for it. You need to have that artifact managed within a repository. So in the middle layer, you have your repositories, and that might be product lifecycle management or application lifecycle management or ERP or something like that. And that's the interface really where we want to connect to. That's going to provide really that permanent article or object that you can then relate to in order to build links to or be able to connect data back and forth from. So we provide connectors to these back-end systems and then provide different processing logic, interfaces, right, like OSLC for link data and SOAP and REST interfaces, and then also secure data exchange, PDF generation, step conversion, and other processes that are around that. So building a whole ecosystem where you can connect your data together independent of what domain you're in or what vendor you're using, and bringing together all these different systems under one hood. So ProSTEP has three core products that we are using for this integration and collaboration. And the first is on the right-hand side. That's our OpenPDM product. It allows you to integrate, replicate, collaborate, federate, and migrate data between these different environments. So we've got different toolkits inside that handle different processes, and then connectors that go to these different systems. And some are PLM, some are ALM or ERP or STM, but allows you to communicate and provide those types of functionalities between systems, including Teamcenter. The second product is our OpenDXM Global X, and that's a secure file transport product that enables you to securely exchange data with your suppliers, making it auditable, and then providing specific functionality like integration with Teamcenter and a file exchange workflow that enables you to do things like quality checks and transformations, so that if you're sending it to your OEM, then you can make sure it has the format it needs, or if you're receiving it, that you can ensure that you're receiving the data and the quality that you need from your customer. And then finally, our 3D PDF product, and that generates automatically from Teamcenter behind the scenes 3D PDFs or HTML5, so that you can share data, CAD data, with other parts of your business or other customers or suppliers, and be able to use CAD data in other places. It just relies on Adobe Reader, and so anybody can look at this data. And really, it's kind of a portable document, but a role-based portable document, so that you can get the data in the right format to the right people. OpenPDM allows you to expand Teamcenter, and so focus really on the different connectors that we have. So first, we're able to provide this functionality of integration, migration, federation, and collaboration using our Teamcenter connector that interfaces with Teamcenter through the SOA interface. So this connector's been around for 20 years or more, and supported for that time too, through the different versions of Teamcenter, and enables you to do a lot of different operations, being able to read and write data back and forth. We also have what we call our controllers for CAD, and that is using UG clone. So if you want to get NX data in or out of Teamcenter, we can do that through that interface. Or if you're using Creo or SolidWorks or CATIA, then we have other controllers that you can use in the bulk operation behind the scenes in order to load or export data out of Teamcenter as well, working with that native data as much as possible. And then we have a wide variety of different functionality, right? So for migrations, we have staging databases and reporting processes in order to ensure that you get the performance sufficient, and can do some data cleanup analysis, things like that. Step toolkits for collaboration, so you can generate step files to send away, to your partners. And automation, really. So this is intended to be working behind the scenes and not really have a whole lot of user interface. Our OpenDXM Global X product allows you to securely and easily exchange data with your customers and suppliers. So that integrates very well into Teamcenter. We've got a client integration, and in that client integration, what you can do if you want to send data out is select the data that you want to send, select the supplier, and OpenDXM already knows what format and what checks it needs to make, or what translation it needs to do, because that supplier has a profile that's stored in the backend. And then when you click go within Teamcenter, all the processing of automation is all done in the backend, and that means exporting the data, converting the data if it needs to be, ensuring that there's all the attributes, and metadata that the supplier or customer needs, doing that type of quality check, and then packaging and finally sending it out securely, and in an encrypted package so that that partner of yours can receive that. So automating all those processes that you might actually have a lot of headache or trial and error with in delivering data. And then on the other way, ensuring that the quality of the data is delivered. So when you receive the data, doing the quality checks and checking all the attributes, and then possibly importing that into your PLM system and incorporating that within the products that are there. We're trying to make this as easy to use as possible as well. So that means we have integrations for Outlook. So instead of just emailing data, which a lot of people do, to kind of fill that security void there, you can pipe everything just automatically through OpenDXM Global X. Other integrations to PLM system. We have Dropbox-like functionality, so you can have a folder and just drop it in there. It'll send it out. And then also, a Send To and Windows Explorer kind of integrations. And these support different standards, as well as, our PDF, the 3D PDFs, OFTP2, and other things. And then finally, our 3D PDF generator that can generate both 3D PDFs and HTML5 using data out of Teamcenter. And this could be done for different purposes, right? So, it could be to, generate maybe a quote package, that goes through your ERP. For archiving, you can use that with conjunction with a step file, possibly for long-term archiving, to capture different data for analysis, or to provide work instructions or maintenance manuals. But really getting the CAD data in an easily consumable format to other consumers of that data that don't want to use the native CAD or even a hard to use visualization client, right? Everybody's already got Adobe installed on their machine, so it's very easy in order to use and in order to be able to process. So we use the same OpenPDM connectors in the background with the SOA interfaces and the CAD data interfaces in order to generate this, and we can tie that into things like releases or updates to data. Obviously, we have a lot of different customers. Our OpenPDM has been around for about 20 years. These are some of the OpenPDM customers, but even more with PDF Generator and GlobalX. And thank you for attending our presentation. My name is Brian, and I'm available at scouting@prostep.com. If you have any questions, feel free to reach out, and I'd be happy to field them.